Tachyons, faster-than-light particles. It is often said that nothing can travel faster than the speed of light. The universal speed limit is approximately 300,000 kilometers per second, and because of the rules the flying spaghetti monster imposed upon the universe during its creation, this limit cannot be broken. Or can it? Theoretical physics describes a type of particle which may be able to break the light barrier. It can also reportedly travel through time. It gets faster as it loses energy, and it possesses imaginary mass. So does this mysterious particle really exist? Let's find out as we explore the truth about tachyons, the faster-than-light particles. Or just another pawn used to further propagate what tachyons, faster-than-light particles. The reason we believe that faster-than-light speed cannot be achieved by ordinary matter is because of the way speed affects mass. According to Newton's first law of motion, if you want something to move faster, you're going to need force from an external source. Stuff just isn't going to move by itself. It's why you need to kick a football to make it move, and why cats will only vacate your lap if you hurl them into the sun. However, this outside force requires energy, and as an object moves faster and faster, progressively more energy is required to accelerate the closer you get towards the speed of light. This is because the mass of particles changes in proportion to their velocity through a relativistic effect. The actual mass doesn't change, but the particle's mass is nevertheless multiplied by a factor, the Lorentz factor. Imagine if your mother told you to buy a kilo of flour. At the classical physics store, the flour costs $1. At the relativistic store, the price is $2. The amount of flour you'd get in both stores is the same, but at the relativistic store, the flour acts as if it were twice as heavy, even though it's not. Hence, the owner is trying to rip you off. So if you're a particle, the faster you go, the heavier you get. It's like the opposite of going to the gym. As a result, faster-than-light travel for most objects with mass is deemed impossible, as you'd need an infinite amount of energy to achieve true light speed. There isn't enough energy in the universe to propel a single electron at the speed of light, and getting close to it outside of a vacuum is impossible. That being said, not everything is beholden to this universal limit. The Cherenkov effect allows electrons to travel faster than light through certain media. The universe is also expanding faster than the speed of light right now. The sentence, "nothing can travel faster than light," can therefore be taken in two ways. No thing can travel faster than light, but conversely, the concept of nothing, as understood by laymen, can also travel faster than light, even though space-time isn't technically nothing. But you get what I mean. It sounds neat anyway. So, as you can see, the so-called universal speed limit can be broken by the universe itself. Still, I hope it doesn't get a ticket. I hear space cops are even more racist than they are here on Earth, and when they find out the universe is full of dark matter, you know they're going to pull it over. Hashtag dark matter universes matter. In truth, the barrier of light speed only applies to matter moving through space-time. Objects subjected to quantum entanglement are also thought to be able to violate the limitations of the speed of light by virtue of their interactions rather than their movements. Furthermore, the phenomenon of quantum tunneling has seemingly demonstrated that photons which move through a quantum tunnel can travel faster than light too. And according to some theoretical physicists, there is a special form of matter which can actually achieve faster than light speeds. A particle with mass which you could only see once it has passed you by. A tachyonic particle. Tachyonic particles were originally envisaged by German physicist Arnold Sommerfeld, but the word tachyon was first used in Gerald Feinberg's 1967 paper, Possibility of Faster-than-Light Particles, in which the physicist explored the potential existence of particles which could break light speed within a vacuum, while also adhering to the framework set out by the theory of relativity. To do this, tachyons employ something called space-like 4 momentum. To explain what this is, let's look at a single particle of pollen. Pollen particles have a time-like relationship with the rest of the universe, meaning that they are causally affected by other events. On this diagram, the The event of the pollen entering your nostrils will be found at the center, where all these lines and cones converge. The vertical line represents time, with the X and Y directions being space. Those two cones constitute places in the universe where light sent towards and from the event could feasibly reach. The bottom cone covers the past, as it covers all the places where light could reach you to cause an event which impacted the particle of pollen reaching your nose. This could be anything, like a gust of wind which blew the pollen to a mean honeybee who decided to place it inside your nose to annoy you. Based on the speed of light, the breadth of these places which could have affected your pollen intake is therefore limited, since anything beyond these cones could not have reached either you, the pollen, or your soon-to-be gunked-up nostrils in time to make a difference. The top cone represents a future light cone, and this contains all the locations in space-time which could be influenced by what happens when the pollen enters your nose. If you're going to sneeze, your snot is heading somewhere in this cone. It too is limited by the speed at which light can travel. An observer at the center of this diagram will experience a trajectory which moves forwards along the time axis. Basically, anything that has time-like momentum can only be affected and have an effect upon whatever exists within the past and future light cones. But tachyons like to play differently. An object with space-like form momentum could theoretically have an impact upon an event even if it existed outside of its light cone. A tachyon could do something 10 billion years into the future, which would cause pollen to head into your nose today. This theoretical ability has been drawn from the way space and time affect each other. The faster an object moves, the slower it experiences time. When you reach light speed, the passage of time should stop entirely, and if you go beyond it, as a tachyon is believed to do, then time should go backwards. One interpretation of how tachyons could work is that they are perpetually moving away from the future against the grain of time. If this is true, then they could potentially hurtle backwards in time to rewrite history. And that sounds kind of neat since I've put on a little weight recently and I could really use the tachyons help me to avoid eating my own weight and brisket every day for the past 6 months. Yet, such an action would immediately seem to violate the laws of causality. How can something which hasn't happened yet take place in the past to affect the present and the future? It'd be like sending your 7-year-old self a message forewarning them to avoid flaming hot Cheetos. They're a gateway snack to obesity, you'd say, but how could this event possibly take place? Surely, you'd have to experience the consumption and subsequent addiction to flaming hot Cheetos to gain the knowledge you're passing on to your former self. So, if 7-year-old you grows up to avoid having a snack problem, how could he become the version of you who warns him about an addiction which never took hold? This example, by the way, is taken verbatim from one of Einstein's papers. He was a notorious cheesehound. The ability of tachyons to travel backwards in time therefore shouldn't make sense based on its effects on causality, and there are a few other problems with it too. The only particles which could achieve a backwards trajectory in time would be those which possess an imaginary mass, and this would have some bizarre effects upon how a tachyon behaves. For example, when a normal particle of matter loses energy, the impact of kinetic force would lessen, and it would slow down. A tachyon would experience the opposite effect, speeding up as it lost energy, with its velocity increasing exponentially towards infinity. No amount of energy exists in the universe which could be sufficient to slow a tachyon down to light speed. Only infinite energy could achieve this, meaning that tachyons must be only able to travel faster than light speed. Zero-energy tachyons would therefore travel at an infinite velocity too. And when all these attributes are combined into a single exotic particle, it's understandable why many theoretical physicists think that the existence of tachyons is completely impossible. So, how do we find out the truth? What can we do to search for tachyons? And what are the consequences if they do or do not exist? We're going to investigate this in our bonus video, The Hunt for the Time-Traveling Particle, which you can watch over at patreon.com/strangemysteries now. For a $2 monthly pledge, you'll gain access to over 100 bonus videos.
Stop. Just watch this.
You believe. What do you believe in? You believe in your beliefs, otherwise, why would you believe them? You are free to believe whatever you want, just like you are free to think whatever you want. Free will is what allows you to be you. The beauty of free will is that it allows you to believe in free will. And nothing can ever take that away from you.
Heart, don't fail me now.
As humans, we are the pinnacle of life on Earth, the species at the top of the food chain. It is even us who controls the fate of the Earth. And it is we who are the puppeteers manipulating the strings of reality so as to coerce it into whatever we so choose.
Take me now.
If you believe that. But what if I were to tell you that there is a form of life, an entity, if you will, that is greater than us? An entity that controls us simply by giving us the illusion that we are the ones in control. What if I were to tell you that every facet of your life, including your destiny, has already been predetermined, and that you, no matter how hard you try, cannot and will not ever be able to change that? Would it be uncomfortable for you to accept that you play no role and have no choice in choosing your own destiny, beliefs, opinions, feelings, actions, or thoughts at all? But that instead, you are just another pawn used to further propagate whatever the true and ultimately mysterious purpose of whatever these beautiful, selfish, lifelike entities wish to achieve. It's only uncomfortable if you believe it to be true. And isn't it only uncomfortable if you choose to believe it's uncomfortable anyway? So which is it? Either your predetermined fate is to safely remain in the dark where you can bathe in blissful ignorance, or you can choose to indulge your curiosity, not knowing what the outcome will be, even if it causes you to lose touch with that one very precious idea we all fight to be sure of, no matter how detrimental that fight may be to us, no matter how much pain we must endure because of it, and no matter how many lives may be sacrificed because of it, including at times our own. The same idea, whoever they are, whisper in our ears so much that we forget that it is they who are the architects of it, of this illusion. Reality. Join our $20 premium video tier on patreon.com/Strange Mysteries and watch our latest premium video, The Nature of Itself. But only if you choose to.